Hi everybody. After posting that announcement on a couple of study tips for Psych 225, I had a student who's in our class email me because she'd taken a class where I was the TA a couple years ago. And she asked that I share with you a workshop that I gave at that point on effective note-taking skills and how to study better for classes. This is a presentation I originally put together for a graduate level psychology class, and then I updated it for my cognitive psychology class. So there will be a lot of stuff in here that is math specific, but at the same time I'm leaving in the cognitive things because hopefully it'll help you study better in your other classes. First off, lecture slides are useful to look at when you're taking and revising your notes, and they're useful if you realize something is missing from your lecture notes. They're not useful when you need to find something in a limited amount of time, say during an exam or while you're doing the homework. A lot of instructors give you all of the lecture slides, and it's a lot to print out, and they're not really useful. I highly recommend that you actually don't print out lecture slides when they're given to you, because a lot of students, when they have the lecture slides, they feel like they don't actually have to write stuff down because it's all there for them. And I think that actually impedes a lot of studying and learning, which is why I don't post full lecture slides in my courses. So when you take an actual lecture class in person, or when you're listening to a recorded lecture like the ones I give you, take notes, but generally do not write down information that is on the slides. You have that information, you can go back and look at that information, but if you're too busy writing it down while you're supposed to be paying attention to the lecture, you're going to miss stuff and you're going to get confused because you're spending too much of your attention to writing and trying to catch up or keep up with what the instructor's saying rather than actually paying attention and thinking about the material. After you do this, use your notes and the lecture slides if you're given the lecture slides, or go through the lecture again but just looking at the slides and not listening to what I'm saying. Look at those two things together and then integrate them into something useful. So whenever you see a blue slide like this is one I added for the cognitive psychology class. What this slide is illustrating is the different stages of note-taking. I know that a lot of people write everything down and you get pages and pages and pages of notes. That's not really useful because you need to organize your information so it's easier to navigate, and also the act of organizing it makes the stuff in your head more organized, which means you're better able to think about the material. In these two images, you can see notes that I took during a class. The black ink are the in-class notes I took. As you can see, they're very sparse, and I left some space in between. The purple is what I added while reviewing the lecture slides. And then the blue is what I added in while reading the textbook. While reading the textbook, if it's something that your instructor didn't really talk about, unless they explicitly tell you that they want you to know things that are in the book that they don't talk about, usually you should just focus on the things that they discussed explicitly. After you do all of the messy note-taking, then you can condense it down and rewrite it into something pretty and useful. What you see here are notes from when I took a stats class forever ago and had to learn about probability. So this was actually, I think, a total of about 2.5 or 3 hours worth of lecture. Every lecture on every topic that I give you can be reduced to about 2 sheets of paper, so 1 piece of paper front and back, if you write it neatly. What you can see here is that I use a 2-color system. You might not care to do this, but I think it's really helpful for me. What I do is I take my notes in one color and then annotate them in a different color. So as you can see in the top right, I have or equals addition and equals multiplication. So that's talking about how you find the probability of A or B, or the probability of A and B, right? And then you can see that I have some equations. You can see Bayes' theorem, which you learned last week, where I have both forms written out. And I have some little pink notes explaining to myself what they mean and what they do. Also, you can see that where I first have the probability of A given B, I have a little pink arrow for myself saying that that vertical line is written as given and that it means that it already happened. As you can see in my Venn diagrams, I have those same little pink arrows pointing to the symbols, the new symbols that I hadn't learned yet, telling me that the little U was a union and the little upside down one was an intersection, right? So if you draw them out like that and then make notes in a different color to point out what the new words and new symbols are, I find that incredibly helpful. So here's something similar. This is the finished product of that couple of pages of black, blue, and purple notes you saw 2 slides back. So it was a whole bunch of scribble. There were layers on layers, right? But once I went through all of those, I typed them up and came up with this 1.5 pages of really nicely organized, easy to look at, read, and understand notes. While it might seem like a lot of work to do this, it counts as studying, right? It helps you out a lot in the future. It's one less thing you have to do when you're actually preparing for the exam. And also the act of doing this is really helpful for your understanding. So one of the questions is, well, if I'm going to condense down my notes and make them so neat and small, what do I include? Most importantly, I would say include definitions. So definitions of new words, but also equations and written explanations of what those equations mean. If you have an equation and you don't know what the different symbols mean or what the output is supposed to mean and how you use it, it's not helpful, right? So if there's new vocabulary and if there are symbols you don't recognize and I tell you that the circle with a line coming out of it is called a sigma, and I say the word sigma like 300 times in a lecture, you should make sure that you know that that thing is called a sigma. Last semester, halfway into the semester, I had a student tell me she couldn't find the circle symbol. So that is very strong evidence that she wasn't really paying attention or wasn't encoding the material as I was giving the lectures. Other things you should include with definitions are key terms and also relationships between terms. So later you'll learn about standard deviation and variance, right? You should define both of those, but also make note that the standard deviation is the square root of the variance. So how terms are related to each other. If you tie them into each other, you understand them better, you remember them better, rather than trying to remember each individual piece of information in isolation. I also recommend that you draw tables and figures because sometimes pictures of things are far more helpful than wordy explanations. You look at it and it makes way more sense. If there is an image in one of my lectures that you want in your notes, you can always pause the lecture and do a screen capture just like you had to for the first assignment. So you can pause, screen capture, and then paste it into your notes or print it and then actually have it as a piece of paper that you can write on. Either of those things are fine, or you can draw it yourself. Personally, I like drawing things myself because it makes me pay attention to the details, because there are parts I might otherwise miss if I had just copied it from another source. As I said, when you include equations, you should always say what the variables in the equations are. You should also indicate how they relate to each other. If equations use symbols you're unfamiliar with, make sure you write down the names of those symbols. It's a lot easier to understand my lectures if you know the words that are coming out of my mouth. Also, if you're having trouble and you want to ask for help, it's a lot easier to ask for help if you know the words for the thing that you need help with. Equations, you should also have them explain what they do and what they don't do. So you get an output, right? And what does that output mean? What information can you get from that? And also, what can you not get from that? And if you need that other thing, how do you get that? You should also include multiple forms of the same equation and note that they are the same equation. I've had multiple instances of students being like, I had 5 equations for this one thing and I totally choked on the exam and didn't know which which one this thing was. And the problem is those are all the same equation. They're algebraically equivalent. The one you use just depends on which information you have more readily available. You can use any of those equations and still get the same answer. It's just that some are set up already for you to be able to do the math more efficiently. Also, for any statistic, you should include the possible range of outcomes. Like with probability, you guys recently learned that it is bound between 0 and 1, where 0 is there's absolutely no chance of this thing happening, and 1 is there's a 100% absolutely certain this thing is going to happen. It's important to include the bounds in your notes, because if you do the math and they come and your answer is outside of that range, you know you did something wrong. You should also show how equations relate to each other. So an example of this is that later on you will be calculating the correlation coefficient, and part of that includes the sum of squared error, which is something you're going to have already learned how to calculate. Here in my notes you can see that I have a little arrow pointing in to show, hey, there's this thing in this equation that has this other equation that you already know. So I put that in there, and then also I put in what it means. So r squared equals equation equals actual words explaining what those equations are. Another thing I like to include in my notes is how changing different things within the equation changes the outcome. That way you know, or you have a better idea of what that statistic actually means. We'll get into this more later in the course, but just know that when it comes up, you might want to organize it in a table. In classes other than this one, especially psychology classes, you should include information on theories. So, say you're taking cognitive psychology with me in the fall, and we talk about the trichromatic theory of color vision. You should know the name of it, who proposed that theory, and also any relevant terms that are needed for that theory. So you'd want to know about cones and rods in the eye, because that's relevant to the trichromatic theory of color vision. When you have multiple theories about the same thing, like say the trichromatic theory of color vision and the opponent process theory, you should also compare the theories to each other. One way to do this is to say what outcome they predict. And also you should include how you differentiate one theory from another, like what makes them separate, distinct theories. About equations. I like to keep organized things of equations just so they're easy to look at when taking exams. Again, you're taking all of your exams at home, so obviously I can't keep you from looking stuff up. But if you have to look up all of the things because you don't know them and you don't have your equations organized, you will run out of time. So please try and keep an organized sheet of equations. I will be helping you with this somewhat during this course by giving you equation tables to fill in when applicable. This picture shown here is an equation table I actually made for myself while taking a statistics class. So since you all now know how to type in nice formatted equations like you did in homework 1, you can totally make yourself a document like this, keep it in Word, and just add to it as the course progresses. You also don't need every form of every equation ever presented, right? Later we'll learn about computational formulas, which basically you have equations for each step of a process, but using algebra you can put all of those into one big equation. So if you're starting from scratch, you don't necessarily have to do each individual step. You can do it in one thing, simplify it, and then plug it into your calculator. You should also know how different statistics relate to each other. As I said before, it's all about learning the relationships. If you don't understand how things relate to each other, you're not going to be able to convert back and forth between them. You won't know what they actually mean, and also it'll be a lot harder to remember the parts that you do know, because one of the things that helps us remember is tying things together with other things that we already know. So making those connections is essential to learning things. Another thing you should include in your notes are processes. So what they're called and how you do them. You might also want to list things out in a step-by-step fashion. Very soon you guys will be learning about the 5 steps of hypothesis testing. Now we're going to learn a number of different ways to test hypotheses, but those 5 steps will always be the same. So include step-by-step how-tos, also include the equations you need for each of those steps. And when you learn multiple things that work very similarly, make sure you draw those parallels, see how things relate to each other. Again, always about relations. If you, for example, understand that the t-test for a single sample works exactly the same as the t-test for dependent means, except that there's one additional step in the very beginning, you don't have to learn a new thing. All you have to learn is that one initial step. And that greatly reduces the amount of stuff you have to learn and memorize and all of that. It makes everything so much easier. If you condense your knowledge and connect it, again, things make more sense. They're easier to tell apart, and it's just less stuff to learn. So this brings us to the question of what you should not include in your notes. Mathematical proofs are something that do not belong in your notes. I generally avoid these in class because I find that at an undergraduate level they do more harm than good. But once you get into higher level classes, if you are shown proofs, you generally don't need to write them down. All you need to do is be able to understand that this is a series of mathematical steps that shows how this thing comes from these other things. Other things you should not include in your notes are example problems. I know it's really tempting because you want to just be able to compare a problem you've already done to the new problem you're doing and just reapply those steps. But if you're using it as a template like that, you don't really understand the material. Also, if the new stuff is presented in a slightly different format, you're just cheating yourself and you won't understand it. You'll get confused, you'll mess it up, you'll lose points, right? So if you do this, it's because you don't actually understand the material. If you feel like you should have worked out problems to look at, that's fine, but I would keep them separate from your actual lecture notes, the things you're going to reference and study from. Just have them as backup in case you need to look at them again. So again, proofs are incredibly frustrating to a lot of students because you're paying attention, you're trying really hard to understand it, and then you're like, oh, I don't actually need to know this. So just be aware that that's a thing when you take other classes in the future. Now, about your homework. I know that you're not actually handing in physical homework, but if you're printing the homework out and working on it, it's much more useful to you if it's neat because you can see exactly what you were doing, when, why, how, and what order. I also suggest that you correct your homework. This is an assignment of mine from forever ago, and you can see the pencil part is what I did when I handed it in. Now, the part in purple is what I got when I looked at the answer key. I know a lot of times you get homework back, you're frustrated, things are marked off, and you're just like, enough, I don't want to look at this anymore. But if you don't go through and make those corrections, then you're not actually going to get it, and you're going to, it's a disservice to yourself when you actually need to know this stuff and reproduce it on an exam. I generally give you guys homework keys that show things that are worked out, but please don't just print those and assume that you know all of the things that are on it. Go through and make notes that are useful to you. I recommend that you make the notes on your actual homework that you worked out, because if you show which mistakes you made and make it readily apparent on your own work, you're less likely to repeat those mistakes in the future. This is more for handwritten things that you guys send to me, and also this is a note from when I taught an in-person class. But another reason to have neatly done homework is that it helps your instructor figure out where you went wrong. And if I can see your mistakes, I can help you address those mistakes. If I've just got a bunch of scribbles and then like a circled answer, or all you do is give me an answer and not show me your work, I can't help you because I don't know what you need help on. I know a lot of people want to scribble and that's how they work and that's how they write things out. But especially if you make mistakes and you have to go back and fix it and redo the problem and you did it wrong the first time and there's a bunch of stuff on your paper that's correct and the bunch that's incorrect, do yourself a favor, go back and rewrite it neatly. Now, in classes where you get exams back, make sure that you do it neatly and do corrections for the exact same reasons I said for your homework. Again, this slide is from a different class where people didn't get to take their exams home with them, but obviously you're already at home and you will be having an exam, so it's already out there. I do suggest still going through your exam and figuring out what kinds of problems you had and what your actual difficulties were. Don't just be like, I don't get math, or hey, I don't understand this entire topic. Figure out where the disconnect is, where exactly your process broke down. It'll help you, and also if you want to come to me for help, it'll help me explain to you in a more succinct and useful manner. Again, taking notes from the text, similar process to lecture notes. Usually you can integrate them as well. But do know that in your textbook, in every textbook I've ever encountered, things are organized hierarchically. So when you have different sections and subsections, pay attention to that organization. At the beginning of the chapter, usually there's a kind of guide of where things are going. So a bullet pointed list or something saying these are the main topics we are going to discuss in this chapter. Your notes should follow that same format. It's useful to understand which things belong together, what is a sub-process of what larger process. If you have everything listed, it's just a list. It doesn't show how things relate to each other. Another thing worth noting is that the text in general, in most classes, the text is meant to supplement lectures. So if it's in the book and your teacher didn't spend much time talking about it, unless they explicitly in the class tell you that there will be stuff in the book that will be on exams that they didn't talk about, or they didn't say, hey, I didn't do a good job explaining this thing, make sure you read this chapter extra carefully. Don't waste your time with it. I mean, skim it, make sure there's nothing there that's completely foreign to you. But don't stress on trying to understand things that your instructor didn't think were important enough to talk about. If your instructor really thought that topic was important, he or she would have lectured about it. If it's in the textbook and they didn't talk about it, they probably don't care about it very much. So the take-home message of this workshop is that developing good note-taking skills will help you for always. And the most important things to focus on are organization and neatness. If your notes are messy, they're hard to navigate, and that makes them less useful. If there's too much stuff in them, they're hard to navigate, and that makes them not useful. If they are hard to read and understand, again, that makes them not very useful. One thing that I like to use to organize my binders are these little sticky tabs. You can see in this picture that there are those tabs on the side. I index my notes by topic. Rather than buying binder dividers or whatever, even if you're using a notebook, you can go to Long's, and in the stationery section, you can buy just those tabs, and they self-stick, and you can just stick them directly onto pieces of paper. I think they're really useful. So this method of note-taking and re-note-taking and organizing stuff is a lot of work, but it's totally worth it. It counts as studying, and also it helps you figure out what you need to study more. If you don't have a good enough understanding of the material in order to integrate it and organize it and point out those relationships, that means that you need to go study that part a little bit better. Also, writing stuff out and playing with it and organizing it, seeing how things work together, fit together, helps you commit them to memory. So it'll help it stick in your head better. Just reading and rereading the same notes you already took doesn't help you understand it. It makes you more familiar with those notes and you feel like you got it, but then when you're actually confronted with a problem and need to use that information, you blank out because you don't have enough experience with seeing it in different forms and writing it and using it. But you've just been able to recognize and become fluent in reading your own notes, which is not really helpful. So here's some evidence-based advice from research in psychology. You can make sure that you understand the material by asking yourself the following questions. So because we want to look for relationships, you can ask yourself, how does it fit with the other things I already know? Also, does it make sense? If it doesn't make sense and it doesn't seem to fit in with other things that you're pretty sure you understand, then there's a part you're not getting that you should probably go back and look for. Another important thing, especially in more theory-based classes, so not my class, but if you, say, took cognitive psychology with me online in the fall, you can ask yourself, how do I know this? So rather than just try and memorize facts and findings, it's important to ask, how did this information come about? How do I know this to be the case? Another thing you can do is study with a friend, and rather than just, ask each other for help when you get to a part that you don't understand, take turns explaining things to each other. If you have to say it out loud and talk through it, you realize how poorly you actually understand stuff, and also if you are able to talk through it and discuss it with someone, you get a much deeper understanding of the material. Deep understanding is really important. If you understand how things work and why they work that way, you don't need to memorize everything. You can use logic to figure things out because you understand the rules of using those things. Another really important thing is that you need to space your learning out. Cramming does not work. This is the reason I give you guys really small homework assignments, but a whole bunch of them. In the past, I've given, one assignment per week, but then everyone waits until the day it's due and does it all then, and then it's junk, right? They turn in junk. If you space it out, you have more time to work on it because I'm kind of forcing you guys to do half in the first half of the week and half in the second half of the week. But also, if you're trying to jam all that information in there at once, it doesn't stick. Based on research on forgetting, the current advice is that all of this review process, do it within a day, or do it the same day that you watch the lecture. So watch the lecture, do the reading, condense your notes. You need to do it right away. If you watch the lecture and then put it off for a couple of days and then do the book reading and then try and make sense of all of the stuff, what you learned in lecture isn't in your head anymore. You need to practice it in order to commit it to memory. So it's really important that you do all of this stuff essentially right away. So if you're doing an in-person class and you go to lecture, later that day between your classes or when you go home, that's when you want to read the textbook. So learn stuff in chunks, right? Space the learning out, but within those spaces where you are learning, put those things together. Another thing, in case you didn't get it throughout this entire presentation, organize, organize, organize. Or physically organizing your notes organizes the things in your head. You won't be swimming around and confused if you know where all the pieces go. And that's it for this workshop. I hope something was useful to you. I'm sorry it wasn't of the usual quality of my videos, but I did this kind of as a last-minute afterthought for you guys. I wasn't actually planning on doing this until one of your classmates requested it. I've heard in the past that this was useful for students, so hopefully it will continue to be useful, and make sure to ask questions if you have any.